Hello, my name is Raymond. I've been watching a lot of physics videos out there, and I have noticed that they haven't explained at all what a space-time graph is and how they actually function. For the most part, they just throw cool little graphics at you, models at you, and just expect you to know what it means. Well, I'm going to run over a couple brief ideas of what a space-time graph is, how to construct it, and then the information that can be derived from it. Now, I just want to say that I am, no expert. I'm just a simple physics student, and I'm putting together just a really brief project, just so that when you look at some of these things, you can fully understand what's going on in those models. Space-time is quite simply a perpendicular shift off of three-dimensional space. An easy object for you to understand in space-time is a tesseract. In order to get to a tesseract, you need to know how to kind of make the shifts from one dimension to the next. In these shifts, they're not arbitrary. We're not just drawing a line off of the next line. Each line represents a 90-degree shift from the lesser dimension. The higher dimensions are built up of objects of the lesser dimensions. If you visualize how to make a cube, it starts off with the first dimension. It's a line. It's built up off of the lesser dimension. 2 points. These 2 points make that line. You get one side with 2 corners. To the second dimension, you take that line and you shift it 90 degrees. So it's an object now made up of lines with 4 sides, those sides being lines, and 4 corners. Third dimension is a cube, but you take a square and you shift it another 90 degrees. And those sides of that are squares. There's 6 squares and 8 corners. So to continue on to the fourth dimension, you take that cube and you shift it again another 90 degrees. So that objects, then all of its sides are made of cubes. And there's 8 cubes in that object with 16 corners. So when you look at a tesseract, you'd be able to see all the sides as corners. And there's no real way to make a tesseract in the third dimension, but you can make shadows of it. That being said, how we make cubes, shadows of cubes, on paper. So we take a three-dimensional object and smash it down into a second-dimensional object. In order to do that, you actually warp one side. Let's say you change that 90 degrees to look like something like 45. When you look at it, a tesseract, you can do this in the third dimension to easily see it. Now you can smash it down to something else into the second dimension, but it gets all wibbly wobbly and hard to actually see. Now that you understand what fourth dimensional space looks like, it being a perpendicular 90-degree shift off of all three-dimensional space, you can start building things like space-time grids. In these graphs, what you end up doing is you take all of space, the third dimension, and you flatten it back out. And then what I did was take another shift, which represents time, in which that grid space sits on the present, and everything above it is all possible futures, and everything below it is all possible pasts. Now, what's built into that grid being flattened, is all third-dimensional space. Now, that's kind of odd to understand, but it's there. So what we see around us is now flat. And now we can actually then have a perpendicular shift of time, in which we can measure time like we measure space. Now some things can happen to this space-time. such as the presence of mass, where it actually bends space-time and it warps it. Now what ends up happening there is that your perpendicular shifts still stay 90 degrees off of that warped space-time. So flat space-time, straight up, easily represented. Now what you can see then through this line over here is that you have a shift where it's going straight out, and that straight out shift is actually heading into the future towards the object. So what that says is that if you're standing still being just a straight line, just a perpendicular shift off of space, you'll actually fall into this gravity well naturally and end up being on the surface of whatever objects in that third dimensional space. That is actually how gravity works. So your future with no motion is actually going to naturally, and you'll end up on top of an object that has mass. Another cool graph to look at is at black holes, where space-time is warped to such a point where all possibilities of light are actually contained within inside the gravity well itself. All in all, what these graphs show is that there's a real connection between time and space. Time actually exists and isn't an arbitrary measurement. And as space continues on, it moves through the dimension of time, and that we are inevitably connected to time expanding into the future from the past. That's all I really got for this quick video. I hope you enjoyed. Thank you.